In section 2 of chapter 1, we're going to be going over point slope form again, but we're going to change things up. The last section, I gave you the point and the slope. This one, I'm not. I'm going to just give you 2 points. We're still doing the same process. We just have a different starting point. So we're still doing point slope form. We're still going to be graphing. We're still going to be doing all the same calculations. The only thing that is different is I'm giving you different starting information. There are 2 ways for us to calculate the slope. Because if I give you 2 points, the missing bit of information we need for point slope form is in fact the slope. There are 2 ways that we can go about doing this. There's one way that I recommend and one way that is technically correct, but it has some major pitfalls that I don't recommend. Here's the first way that I recommend. If you're given 2 coordinates and you want to find the slope can be calculated using the slope formula. The slope formula is, there's different variations of it, but this is the one I like to use, y1 minus y2 over x1 minus x2. That will get you the slope. Now, depending upon what field you're looking into, they might change this up a little. If you've taken some science classes, specifically physics, another way that they also write this is the change in y over the change in x, or delta y over delta x. Delta is that little triangle symbol. It's a Greek letter. It means change. So if you ever see that in mathematics or in any of your science classes, it's just measuring the change in something. So delta y simply means the change in y, how y is going to be changing. It's a measurement of how it's changed. So that's going to be one way you can calculate the slope. There's a second way, and I actually just have to give an example to go through it with. This is a method I do not recommend because it has some major issues with it. If I give you a graph with 2 points, the other way you could calculate the slope is the slope you can find by counting how many times it goes up. 1, 2, 3, 4, 5. Over how many times it goes to the right. 1, 2, 3, 4, 5, 6. Slope is 5, 6. You can just count. The reason I don't like that is it has some baked-in assumptions. One of which is you're assuming that those dots are at integer values. You're assuming they're not at decimal values. The other thing is, if you just make one tiny counting error, you're going to be off. And you won't be able to find your error. It's really hard to check your work when your work is just tracing along with your finger. That's why I don't like that technique. You can do it, it still works, but it's got some major flaws to it. All right, so here's my first example. I have 2 coordinates, 3, 2 and 5, -1. I am going to be finding the slope in between those 2 dots, and I'm going to write that as an equation in point slope form. So first, got to calculate the slope. Slope is going to be equal to y1 minus y2 over x1 minus x2. That's going to be equal to 2 minus -1 is the same thing as 2 plus 1. 2 plus 1 is 3. 3 minus 5 is -2. Typically, we like writing the negative in the numerator in the top part of the fraction, so I'm going to rewrite that as -3 over 2, and there is my slope. Now, I do want to mention what we just did works. It doesn't matter which one you consider the first coordinate and which one you consider the second coordinate. They'll both work. I could have, instead of starting with the red values, I could have also started with the blue values. It will get the same answer. -1 and then 5 on the bottom, minus then the 2 and the 3 as the second terms, you'll get the same answer. -1 minus 2 is -3. 5 minus 3 is 2. We got the same slope. The reason for that is the formula says y1 minus y2, where y1 is the first coordinate, y2 is the second. Picking your first and second coordinate, that's an arbitrary decision. Doesn't matter which one's the first and which one's the second. The only thing that does matter is that these two numbers have to come from the same coordinate. These two numbers have to come from the same coordinate. If you start mixing and matching, that's when you'll get it wrong. And once again, I could have also just graphed the two dots. Right 3, 1, 2, 3, up 2, there's my red dot. Right 5, down 1, there's my blue dot. And I could have just simply counted, oh, I went down 1, 2, 3, and right 1, 2. I still get the same slope. And then I would just graph my line. Ultimately, our goal is to write this in point slope form. And this is the other trick to this, because I could write it as y minus 2 equals negative 3 over 2 times the quantity of x minus 3. That is the equation of that line. That is 100% correct. There is nothing wrong with that. I use the red coordinate along with the slope to put it in point slope form. I could also do the exact same thing using the blue coordinate. I only need you to do one or the other. I'm going to show both. So I could also write this as y plus 1, because that 1 is negative for the blue coordinate, equals negative 3 over 2 times the quantity of x minus 5. These are both the same function, they just start at different locations. I just want to do this one last time from beginning to end with another set of coordinates, just to review the process. I am going to, given two coordinates, find the slope, write the equation, graph the line. I can pick whichever one to be my first coordinate, whichever one to be my second coordinate, but ultimately slope is going to be equal to, in my example, negative 3 minus negative 1 over 5 minus negative 1. Negative 3 minus negative 1 is the same thing as negative 3 plus 1, because we're subtracting a negative, and that's just adding. Negative 3 plus 1 is negative 2. 5 minus negative 1 is the same thing as 5 plus 1, which is 6. Negative 2 over 6 is reducible because the numerator and denominator are both divisible by 2, which means the simplified slope is negative 1/3. Now that I have the slope, I can use either the red coordinate or the blue coordinate to create the equation of the line. It does not matter, they're both correct. Just pick one. I'm going to pick the red one because the blue one just has the same number twice. So the equation would be y minus the y value, which is negative 3, so that'll turn into a plus 3, equals the slope, which was negative 1/3, times the quantity of x minus the x value of my coordinate, which is 5. And now I have the equation in point slope form for my linear function that goes through those two dots. So let's graph. I went right 5, 1, 2, 3, 4, 5, down 3. There's my red dot. And then my slope is negative 1/3, so I'm going to go down 1, right 3. I don't have enough room to go down 1 and another right 3, but I could follow the pattern backwards. Up 1, left 3. Up 1, left 3. Up 1, left 3. Up 1, left 3. And this is my line. I want you to notice a few things about my graph before we call this an end. First, my line extends to the outer edges of my graph. I need you to do that. I don't want a short line. I want it to extend to the perimeter of the little box that the graph is encompassing. Additionally, I need it to end in arrows. If you end it with a dot, that's called a line segment. That means it terminates there. It stops there. An arrow signifies that it keeps going forever, and that's what these do. And then third, notice that I never graphed negative 1, comma negative 1. But if I followed the pattern, it naturally went through that dot anyways. Because it does not matter which of the two dots I started with. They are both on the line. As long as I follow the line, starting at one of those points and using the slope, it will automatically go through the other line.